everyone. In our previous video, we have seen how to solve a homogeneous differential equation when we have the case of the form AE not equal to BD. So this is a second example where we have one more example of the same type, that is to solve a homogeneous differential equation. So we'll consider this example. So our example is dy by dx that is equal to x plus y plus 4 divided by x plus y minus of 6. So let's compare this with the standard form. So comparing with the standard form, so we know that the standard form is dy by dx that is equal to ax plus by plus c divided by dx plus ey plus of f. Now we need to check if AE is equal to BD or not equal to BD. So compare it with the given equation. So let us take this equation as equation 1. So we can see here coefficient of x is A and here it's 1. So it is 1 multiplied by. E is in the denominator as a coefficient of y. So here the coefficient of y is 1. Also compare BD. B is y coefficient in numerator. So here it is 1. D is coefficient of x in the denominator. So it is again 1. So we can see that 1 times 1 is equal to 1 times 1. So we can see that this is of the type case 2, right? So when you have example of the type case 2, then what we are going to do? So what we do is we look at the equation, and here since x plus y is same and whatever equations where you have AE is equal to BD, what we usually do is we take the x plus y whatever thing you have other than the constant as equal to some another variable z. So we take put x plus y equal to some another variable z. So again remember, if I have here 2x plus y and again here 2x plus y, then again I'm going to take it as z itself. So whatever you have here, this term or this term, as they are same, they will be taken as equal to some z. Now what we do is we differentiating with respect to x. So as I already mentioned, x, y, z, 3, all the 3 are variables. So when you differentiate with respect to x, x with respect to x will be 1 plus y. When you differentiate with respect to x, it will be dy by dx, and z will be dz by dx. So now if you see the equation 1, we have dy by dx. So we'll see what will be the value of dy by dx. So this will say that dy by dx value is equal to dz by dx, as it is plus 1, which becomes minus 1. So let us put the value of this, that is x plus y equal to z, and dy by dx is equal to dz by dx minus 1 in equation 1. So substituting x plus y is equal to z and dy by dx is equal to dz by dx minus 1 in equation 1. What do you get? We know that dy by dx is dz by dx minus 1 equals x plus y is z. So it is z plus 4 divided by z minus of 6. So we can see here we have obtained an equation where you have terms in x and z, right? Variables as x and z. So now we have to go for separation of variables. So before that, since you have here minus 1, take minus 1 on the other side. So therefore this equation will be dz by dx, that will be equal to z plus 4 divided by z minus 6 minus 1 on the other side plus 1. So when you simplify this further, dz by dx will be equal to z plus 4 taking LCM plus of 1 times z minus 6 divided by z minus of 6. So dz by dx as it is. Now simplify this further. Z plus 4 remains as it is. Plus of 1 times z is z plus minus is minus. 1 times 6 will be 6 whole divided by z minus of 6. So therefore dz by dx will be equal to, see we have two terms in z, this is z and this is z, so this becomes 2z. 4 minus 6 will be minus 2 whole divided by z minus of 6. So we have this in the simplified form. So now everything is being simplified, so it's time to separate the variables. So as I told you, variables are x and z, so we need to separate variables. So on separating variables, so when you separate the variables, take all the z terms on one side, take the x terms on one side. So x we have only one, so send x to the numerator on the right hand side. So this one will reverse and we get z minus 6 divided by 2z minus 2, 2z minus 2, and we have a dz equal to this dx to the numerator. Always remember dz, dx, whatever you have should be in the numerator. We cannot take it in the denominator because we are going to apply the integration in the next step. So now we can see that the variables are separated. So once we separate the variables, we need to integrate. So in the next step, since variables are separated, integrating, what do we get? We are going to apply integration on both the sides of the integral. That is integral of z minus 6 divided by 2z minus 2 dz equals integration of dx. So we can compare this again, z minus 6 divided by 2z minus of 2, which is equal to dx. So this is how we get the integration. Now you can see here 2 is common in the denominator, so we can take 2 common. So that becomes 1 over 2 in the denominator, 1 over 2 common, integral of z minus 6 divided by z minus of 1 dz, that equals integral of dx. So now we have to integrate this, so we don't have any form where we can apply the integration directly. So what we have to do is we need to simplify. So you can see that z and z is same, right, in the numerator and denominator. But if we can make minus 6 as minus 1 by doing something here to the numerator, then we can cancel one term. So what we can do here is 1 over 2 can be kept as it is. Integration of, I can write z minus 6 as z minus 1 minus 5. That is nothing but again a minus 6 itself, whole divided by z minus 1. So I can see here this term and this term is similar, so they both are same, so I can cancel them. So since 1 over 2 is disturbing, I'll send 1 over 2 on the other side, that becomes 2. So here I'll be having integration of, say I told you I'll be separating, so I'll take this as a single term and this as one term. So it becomes z minus 1 divided by z minus 1 dz. I'm taking integration separated to the both of this term. So I've taken this term minus integral of 5 divided by z minus 1 dz, and that's equal to, sorry, I try to write this as dx here. This 2 goes on the other side, so it becomes 2 integration of dx. Now, so these both are similar, same, so I'll just cancel this both. So we'll be having integration of 1 dz minus 5 is a constant, take it out, so it is integration of 1 divided by z minus 1 dz, and this is equal to 2 integral of, since there is nothing, I can say it is 1 dx. So now it's in the simplified form. We need to apply the formulas of integration. So integration of 1 dz will be z minus phi is a constant. 1 over z minus 1 can be written as log of z minus 1 equals 2 as it is. So integration of 1 with respect to x will become x. Remember here we have z, so I have taken the integration as z. Here we have dx, so the integration of 1 dx will be x. So it was again an indefinite integral. So once we finish integrating, it's always important to add the constant of integration c. So we have done everything, integration is done, but that doesn't mean that this is the solution, final solution, because we had started with x and y. So it is very much important that the final answer to be also as x and y. So remember, we had taken x plus y is equal to z. So same thing will be replaced here. So what we do is replace z by x plus y, right? We had considered z as x plus y in the beginning. So therefore replace z by x plus y. Therefore what do we get here? X changes to x plus y minus y as it is, log of, again x is x, z is x plus y minus 1, that's equal to 2x plus of c. So now it is in simplified form, but let's simplify this still more. So instead of taking it as x plus y, since we have two terms in x, this interior term of log cannot be done anything, but x we have two terms, we shall make it a single term. So this will be y minus phi log x plus y minus 1 equal to, we had 2x plus x here, on the other side becomes minus x plus of c. Now therefore if we need to simplify this, 2x minus x will become x. Therefore y minus of phi log x plus y minus 1 equal to x plus c will be our required solution, is the required solution. So in this thing to remember is how you need to do the integration, and then always remember to replace whatever you had changed in the question. So I had changed x plus y to z. So in the end, I am going to replace x plus y in place of z. And this is how we get the required solution. So if you like my video, please like, share and subscribe, and please stay connected for more videos. Thanks for watching.